Please like, share and subscribe to this channel FM Education Academy. The first question is, for each geometric progression, find the common ratio R and then find An. We are going to do second bit and fourth bit of the first question now. So, it is asking me to find the common ratio R and to find the nth term An. The series is given to me. So, first term a1 that is equals to a is equals to 2 here. Second term a2 is equals to minus 6. Third term a3 is equals to 18. Fourth term a4 is equals to minus 54. Now, we already know our a. Our a is 2 here. A is always the first term. And common ratio we can find out either by taking the second term by first term, or we can take third term by second term, or we can take fourth term by third term. Here I am going to take second term by first term. Only one if you take it is enough, because already it is telling in the question that this is in GP. It is confirmed that they are in GP. That is why we take only one time R. So R is equals to A2 by A1. A2 I have is minus 6 and A1 I have is 2. 2 1s are 2, 2 3s are 6. So R I got is minus 3. Now we have A, we have R. It is asking me to find out nth term An, right? The formula for nth term of GP is A into R power n minus 1. So nth term of GP An is equals to A value is 2 into R is minus 3 power n minus 1. Since we cannot expand this minus 3 power n minus 1, and even if we expand we cannot simplify it. So we'll stop here. So this is my nth term. So I have found out R and An. It is told me to find out common ratio R and An. So I will write here common ratio. Therefore, common ratio is equals to minus 3 and nth term An is equals to 2 power An is 2 into minus 3 power n minus 1. Similarly, we will do the fourth bit. Fourth bit also same question. Geometric series is given to me. They are asking me to find out common ratio R and An. So A1 is 5 here. A2 is 2. A3 is 4 by 5. A4 is 8 by 25. Common ratio R is equal to second term A2 by first term A1. That is equals to second term is 2 here. First term is 5 here. We found out R. Now, let us find out nth term. An is equals to A into R power n minus 1. Same formula. An is equals to substitute. In place of A1 is nothing but A. We know that. So, A is 5, which is the first term always. So, 5 into R. What is R? 2 by 5 power n minus 1. Right. This is my nth term. I'll stop here. Let us move to the second question. Find the 10th term and nth term of GP 5, 25, 125 on. There is infinite series of the GPs given to us, and we are asked to find out the 10th term and the nth term. You know, we can find out the 10th term by the formula An is equals to A into R power n minus 1. So here, since it is telling me 10th term, An is equals to, first I will write what is first term. From this first term A1 is equals to A, that is equals to 5. Second term A2 is equals to 25. Third term A3 is equals to 125. Common ratio R is equals to A2 by A1, that is equals to 25 by 5. 5 1s are 5, 5 5s are 25. So I got the value of common ratio R as 5 and first term A1 as also 5. So here A value is 5. Substitute in this formula of An. Here first I will find out the 10th term, because it is telling me to find out 10th term. So A10 is equals to 5 into R is 5 power in place of n. N, since we are taking here An is equals to A into R power n minus 1. This n and this n both are same. So since here it is telling me to find out the 10th term, means 10th term is A10. So 10 will be similar to this 10. So R power 10 minus 1. Observe, compare both the equations. In place of n, I am substituting 10 here. So here also in place of n, 10, and I am substituting 10 here. So A10 is equals to 5 into 5 power 10 minus 1 is 9. So we know 5 can be written as 5 power 1. This is compared to the formula A power m into A power n. a power m into a power n is equals to a power m plus n. So LHS form is given to us. We will write in the form of RHS. So A10 is equals to a is 5 power m plus n. M is 1 plus 9. So A10 is equals to 5 power 9 plus 1 is 10. So I got the 10th term as 5 power 10. It is also asking me to find out the nth term. Nth term means an is n only. So an is equals to a into r power n minus 1, or an is equals to a is 5 into r is 5 power n minus 1. Expand this. Both are 5 here. So I will expand this. I will open this irrespective of the first sum. Both were not same. So we stopped there only. How to do? Here we can write this as 5 power 1. So it is a form of a power m into a power n. A power m into a power n is equals to a power m plus n. So here observe, m is 1, and from the formula if I compare this n with this n minus 1, 5 power n minus 1. So a power n, a power, this whole is n. So n is n minus 1 here in the formula. This n and this n minus 1 are different. Remember this. This whole is n here because you're comparing with this with a power n. So that is equals to 5 power 1 because m is 1 plus n is n minus 1. So n minus 1. Now here I have plus 1. No sign is there means it is plus. So plus 1 and minus 1 both will get cancelled. The answer is 5 power 1. So the nth term I got is 5 power n, and the 10th term I got is 5 power 10. So the third question is, find the indicated term of each geometric progression. There are two bits in the third question, of which we are doing second bit. First bit is homework. So second bit is a1 is equals to minus 12. That is first term given to us in the question is minus 12, because we know a1 value is equals to the first term always. And r is equals to 1 by 3. It is asking me to find out the sixth term. So it is already given me that a series is there. Okay, a geometric series is there, and in that geometric series it is asking me just to find out the sixth term. Indicated term here means I have to find out the sixth term a6. Indicated means whatever it is asking me. If it asks me suppose fifth term a5, then I have to find out a5. Here it is asking me sixth term is my indicated term, so I have to find out a6. The data given to me is a and r. Very easy. We can use the formula of nth term an is equals to a into r power n minus 1 to, because in place of n, here a6 is n. So in place of n, substitute 6. So a6 is equals to, a value given to me is minus 12. So we'll write here a1 is equals to a is equals to minus 12 into r. R is 1 by 3 power n. N is 6 here because you're comparing this, both n and n are same. So here 6 and 6 are same. 6 minus 1, that is equals to minus 12 can be written as 4 3s are 12. So I'm writing 12 as 4 into 3. Minus is as it is into 1 by 3 power 6 minus 1 is 5. So here if you observe, minus 4 into 3 can be written as 3 power 1, because 3 power 1 is 3 only. So I'm writing 3 as 3 power 1, and here I have into 1 power 5, because this 5 belongs to 1 as well as this 5 belongs to 3. So I will write this as 1 power 5 by 3 power 5. This 5 belongs to numerator as well as denominator. So here if I observe, this is 3 power 1, here this is 3 power 5. Both 3 are present. Right? If I can expand this 3 power 5 as 3 power 1 into 3 power 1 into 3 power 1 into 3 power 1 into 3 power 1. There is 3 5 times as 3 power 5. So 1 3 I can cancel from here. What will be left? Only 3 power 4 will be left, because 1 3 I am cancelling from 5. So 3 power 4 is left, and here 1 3 is left. That is 3 power 1 1za and 3 power 1 1za. So 3 is getting cancelled here. So only 3 power 4 is left. So my a6 is minus 4 into 1 power 5 is 1. We go to 1 into 1. How many times we multiply? We get the number as 1 only. So minus 4 into 1 by 3 power 4. So 6th term a6 is equals to 4 1s are 4, and here I have minus. So minus 4 by 3 power 4. This is my 6th term. Hope you have understood this. Now let us move to the next problem. So the next question is, which term of the GP root 3, 3, 3 root 3 up to something is 729. This is 3, okay, root 3. So whenever it asks in the question, which term of the GP is 729, means it is asking me the position of the term. That is, where is the term placed? Where is the term placed means I have to find out the value of n. Remember this. This tip is useful for AP as well as GP. Whenever it asks which term of the GP means I have to find out the position of the term in this whole series. This is an infinite series. So where is that term placed in this series? That you have to find out. That is, you have to find out the value of n. And this always which is given is the nth term an. Which term of the GP, root 3, 3, 3, root 3 up to something is 729. Means, let us suppose my nth term is 729. Because we don't know the value of A6, whether it is 729 is A6 or A5 or A4, we don't know. So we are assuming that let AN is equals to 729. That is, I'm assuming that let my nth term be 729. A1 is root 3, A2 is 3, A3 is 3 root 3. So find out R. Already geometric progression is given to me. So one time I'll find out R. Second term by first term. Second term is 3. By first term is root 3. Since I have root 3 in denominator, I will expand this 3 as root 3 into root 3 because 3 can be written as root 3 into root 3. So 3 I will expand as root 3 into root 3 by already root 3 is there here. So root 3 ones are root 3. Root 3 ones are root 3. So root 3 ones are root 3 by 1. Root 3 by 1 is root 3. So I got the value of R as root 3 and I got the value of A, that is equals to A1 as root 3. Right, both are root 3, observe. Now, substitute, since AN is given to us, A is given, R is given, we can use the formula of AN and substitute all this value in the formula of AN. What is the formula of AN? AN is equals to A into R power n minus 1. So, AN is equals to A into R power n minus 1. AN is 729, substitute, is equals to A is root 3. Into R is root 3 power n minus 1. Now, 729 will keep as it is only. Root 3. This can be written as root 3 power 1. Now again, it is in the form of A power m into A power n. A power m into A power n is A power m plus n. So here m is 1 if I compare. And here n is n minus 1. Don't get confused in this n and this n. This n is equals to this whole n minus 1 value. So 729 is equals to root 3 power 1 plus n minus 1. That is, I'm writing in this RHS form. This is LHS form given to me A power m into A power n. Nothing is there means which sign is there? Into sign is there. So here plus 1 and minus 1 will get cancelled. Now since this is written in terms of root 3, I will write this 729 also in terms of root 3. Because here 9 is there means it will go in 3 table. If it goes in 3 table, we can expand 3 as root 3 into root 3. So I will find out in terms of root 3 how to write this. We will find out by prime factorization. So 729, 3 4s are 12, 3 3s are 9. 3 8s are 24, 3 1s are 3, 3 2s are 6, 8 minus 6 is 2, 1, 3 7s are 21, 3 3s are 3 9s are 3 3s are 3 1s are. So how many times 3 we are getting? 1, 2, 3, 4, 5, 6. So this 3 can be expanded as root 3 into root 3. Similarly, this 3 can be expanded as root 3 into root 3. Similarly, we can expand the remaining 3s also as root 3 into root 3. So how many 3s we have? That will double. Because 1 3 consists of 2 root 3s. So I will double how many 3s I am having. I will double and write it as root 3. Okay. It is the same thing because 1 3 can be expanded as 2 root 3s. So 2 and double both have the same meaning, right? 1, 2, 3, 4, 5, 6. There are 3, 6. So 6 2s are 12. So it means that there are 12 root 3s and 3 6. Right? Because 3 consists of 2 root 3s. So 729 can be written as 3 power 6, that is equals to root 3 power n, or we can write it, we want in terms of root 3 to compare both. Because when bases are same, powers will be equal, right? So we want to compare the bases. So we can write, instead of 3 power 6, I can write as, because I have to double, root 3 power 12 is equals to root 3 power n. Now both the bases are root 3, root 3. So when bases are same, powers are equal. What are the powers? Here I have 12, here I have n. So when bases are same, powers are equal. So here I got the value of n as 12. So what I will write? Therefore, which term of the GP it is asking now? 729 is the 12th term of the GP. That is, 729 has to be placed on the 12th position of the series. That is what is asked. Hope you have understood this concept. If you have understood this concept, please don't forget to like the video and also subscribe. I think you're enjoying this chapter.